So what are things that you should remember about logarithms? Like, give me something that we talked about.
They're an exponent.
They are an exponent. What else?
Like log base or whatever. Log base, exponent, and then
Oh, okay, so let's start with that one. So,
log base, and then like the answer thing,
and
okay, so does the actual letters we choose matter?
no.
No, okay, so it doesn't matter at all. And so this is equivalent to what? N. All right, so if you only remember one thing about logarithms, this should be it. Okay, this is the main thing. This is the definition of a logarithm, essentially. So this would be it. But there were three other things that hopefully you do remember, and they had names and...
The properties or whatever.
Yeah, so what, do we remember what the properties were called? Okay, so product, quotient, and then power. I'll fit that one in when I know where it is. So can you describe the product? And let's do the product first.
Product was like log B with an M.
Okay, and again, the letters don't actually matter, right?
And then log plus log B N equals log B M times M.
Okay, and so then, oh, that kind of didn't work out, did it? So we'll do, oops, let me do this. Okay, then the quotient would be what?
Same thing but minus, and then at the end it's division.
Okay, so like this. Yeah, so then that equals
And
this. And one thing to remember, the first statement is your numerator. And then the power was what?
Oh yeah, it equals P.
oh yeah.
All right, so do we remember these things? Okay, so then a couple, one other thing that we need to remember. What is the base of this? 10. Okay, so if it's not written, it is 10. Okay, so then if you're looking at the calculator, which hopefully you have because you do need it, you have the log button, and if you look right above the log button, there's a 10 raised to an x power. And that's because they're related. But if you look down one button, you see the button that is ln. Okay? And this is called the natural log. And it also has a thing above it, and it's e. Now, e is this irrational number that shows up a lot in sciences, and you can derive it, but that's unnecessary for us, and I do want us to proceed forward eventually. So just know that is irrational number, which means what, firstly? What does irrational mean?
It's not real.
It's not rational.
No, it is real. It's not rational, which is a fair assumption, but then you have to know what rational means also. So irrationals are real, though. The only non-reals are imaginary.
Isn't like a decimal.
Okay, so listen, please. The technical way to say what she just said is that you cannot write it as a fraction, and that's because it's a non-repeating, non-ending decimal. The most famous of these numbers is pi, but we've been dealing with a lot of them lately, like the square root of 2 is irrational, the square root of 7, anything like that. So e is just another one of those, and it's 2.7 something, okay? And again, it's big time enough that it has its own little button there. And again, it shows up in the sciences and all that. So here's kind of the important stuff for today. The natural log of x, let me get that better. So the natural log of x is the same thing as log base e of x. And in this case, I don't remember what it is. I think 2.71 something. And again, there's something that we can do to show how it got derived. But again, it shows up in the sciences. So, and just to be clear about this is a actual number. This is not a variable any longer. All right, so that's the big thing of the day. Is that okay with everybody? Okay. And so what this means, and we're kind of skipping like a section here because hopefully it makes sense. Any logarithm property or statement we've made about logarithms applies to the natural log. Okay, so the properties are still the same. The product property applies to it, the quotient property applies to it, the power property all applies to it. Is that okay with everybody? So, there's a lot of ways to think of a logarithm. I told you to think of it as an exponent, but it is also an operation, just like any other operation dealing with equations. So this is no different than adding and subtracting, multiplying, dividing, squaring, square rooting, etc. One of the things that you do need to do, though, is if you decide to introduce a logarithm into your equation, it has to happen to both sides. So it's more like a squaring or a square rooting, which should hopefully make sense because these are also exponents, and when you're dealing with exponents, it's to a whole side. Ideally, all numbers can break down into the same base, but this one can't. We can't get 28 down into 5 to any power. But we still need to solve for this exponent of x. So I have no new information than what I just shared with you about the natural log. And if you understand that a logarithm is just another operation, what should we do to try to get the answer to x here? Bless you.
Don't we switch the form?
Okay. So what you just said, Devin, doesn't work because we can't manipulate 28 to get us anything that's close to 5. Okay, ideal. That'd be sweet if we could, but we can't. Well, but then it's some weird number, and that we don't know that that's going to be 5 to anything. So we would like to switch the other form. But what's missing right now? Okay, actually that would work just fine. But let's not do that right now because I want you to use a logarithm like an operation. Okay, so I think what you said here is very legitimate and we could do it. But let's save that idea for a little bit later. Okay. So what you can do is, since it is an operation, you can just introduce it. Like you could say, I want to multiply by 7, but that doesn't get us anywhere. So what we're going to do is just say, well, I want to take the logarithm of both sides. And as long as you do it to both sides, it's a legitimate thing to do. So this didn't really get us very far with the x yet. So what can we do now to get this x by itself? Because again, that's what we're trying to do.
Put it in front of the wall
Why are we allowed to do that?
because of the exponent power, whatever.
Yeah, okay, so the power property says we're allowed to rewrite this as x times log of 5 equals log of 28. Now, log of 5 is just a number. It's obnoxious, it's some weird decimal, but it is just a number. And log of 28 is also just a number. So this problem is no different than if it was 2x equals 7. But it's not 2x, it's log of 5. So how do we get x by itself? Divide by log of 5. Now please be careful on how you put this in your calculator. The way I do it so that I don't have to worry about the parentheses is I just hit log of 25, or I'm sorry, log of 28, enter, and it gives you a number, and then immediately hit divide by log of 5. But if you do that, and I need 4 decimals here, what do you get? 0709? Is that what you said?
2.0704.
Oh, 4, okay. Make sure you can get that. Is that okay? Okay, so since I'm doing it on this thing, I'm going to do this a little bit differently than I did earlier. I want to talk about this problem. I'm going to actually talk about this problem 2 more times. And so right away, I'm going to do it right now. All right, so let's say you say, oh, log, I don't need it anymore. I don't even understand what it's doing. What if we took the natural log of this? Well, let's find out. That has the same properties. So instead of taking log of both sides, let's write down the natural log of both sides. And like I said, the natural log has the same properties. So then we can still apply the which? We can still apply which property?
The power property.
Yeah, the power property, the exponent property. Basically, we say, well, this is the same as x times the natural log of 5 equals the natural log of 28. Which means we would still divide, these are still just numbers, we can still divide natural log of 28 by the natural log of 5. So then when you do natural log this time, what do you get?
You point to the same answer.
You get the same answer, okay? So the log function, if you want to think of it that way, just can allow you to manipulate these exponents around to get there. So you could choose log all day long, or you could choose natural log all day long. It doesn't make any difference. Okay, and so I'm going to actually come back to this problem and do it one more time for those of you that like math. All right, what are we going to do?
So it's just x times ln equals ln 12.
Okay, so you pick natural log. That seems like a natural thing to do because we have an e in there. So I'm going to add the step that you kind of skipped, which is you don't have to, but right, this is natural log of e to the x equals 12, but then he applied the power property again and got x times natural log of e. And as long as you understand what that's about, then, oops, that has to equal. I get so carried away by the sound of my own voice. Which on one of my videos on YouTube, someone commented that they hate my voice. Which was like, well...
So do you have them, or is this just some random person?
Well, it could be, maybe I have them. I think it's a random person, but maybe I do have them. I don't know. But it's like, well, I didn't ask for the velvety voice I have. I just, was given to me at one point. Huh? So I apologize if you don't like my voice, but
It is what it is.
yeah, what do you want me to do about it?
Were you sad when you saw it?
Yeah.
Can't change your voice.
I could. Let's do the rest of this video in a falsetto. All right, so now what's the next step?
Go back to the other voice.
I like this one better. You like this one? Okay. So we still need to get x by itself. What is it?
Kills the vibe.
All right, so how do we get x by itself? Divide by what?
ln.
All right, so the natural log of e. And so then, again, make sure you guys put this in your calculator right. I would do natural log of 12, enter. and then divide by natural log of e right away, and then we get what?
So since isn't e ln, does e equal ln?
We're gonna talk about that kind of here in a second. So just give me a second, and then
Can we just insert x
For E?
Because that's what I did.
no, you need to make sure. Thank you. I skipped it. So there's two places on this calculator that have e. The e above the division sign can be used, and that's just e to the first. Or you can go down to the above the natural log button is e to the x, and you would have to enter the exponent, which again is first in this case.
Bam.
Okay, and so then what do we get on that?
2.485.
Yeah, let's go 4 decimal space. So 4849.
Yep.
Is that okay?
I ordered this around though.
So 2.484.
Well, I wanted it to 4 decimals. Are you supposed to round up and then it gets to 5? Like you round? Is it?
Ball's gonna.
No. Okay. Yeah. Yeah, it's a 0 after that. Okay. All right. So Dylan just asked about, well, isn't e just a natural log? So I'm going to leave this up right now, but I want everyone to do this. So enter in your calculator natural log of e, and what does that give you? 1. Okay, so then enter in the natural log of e to the third, and what is that? 3. And then enter in natural log of e to the 723rd. 723. Okay, so then, oh, it gave you an error. It was too big or something. Okay, but it would be 723. Okay. So then what is? Well, so here let me say this about. Let me say this. Let's look at natural log of e to the third equals 3. What if I wanted to change that to the other form? What would it look like?
Put the 3 in front of the ln.
Well, let's not do that. Right now, this is the same as log base e of e to the third equals 3. So then if I change it to the other form, it would be what?
3 log e
Is that okay? So then, the question was, isn't e the same as natural log? Well, so the answer is no, but what could you kind of look at them as? Well, for sure an exponent, for sure. And think of it in terms of solving an equation.
They're both x or y.
So look up in this area. If the natural log of e to the first is 1, and the natural log of e to the third is 3, and the natural log of e to the 723 is 723, then what would the natural log of e to the x equal? X. So then if you're thinking in terms of an equation, how are e and natural log related? Because again, we're trying to solve for an exponent here. Well, how do you solve an equation in general? Like if I just said generally, explain how you solve an equation.
Just depends on the equation.
Huh?
Depends on the equation.
Well, right, but you use what to get it taken care of? Opposite operations or inverse operations. So I would call natural log and e kind of inverses of each other. Is that okay? Because it kind of just like they cancel each out, kind of. All right, so quicker.
Can you just eliminate the e?
There, listen. Come back. Can you just eliminate the e only if you do what?
If you make it natural log.
Okay, so if we take the natural log of both sides instead of going through this, then this would just be natural log of e to the x, we've all agreed is just x. So then x equals the natural log of 12. So it doesn't just equal 12, it equals the natural log of 12. And so if you type that in, then you get 2.4849. Is that okay? What is log of 10? No.
100? No.
We'll type it in. Tell me. 1. What is log of 10 to the third? 3. What is log to the 10 to the, we'll do a number 7.
7.
Okay, so then what's the base on this problem right now?
10.
Log base 10 of 10 to the third is 3. So then what can we say about log base 10 to the x
X.
is equal to x? So let's go back to that first problem that we looked at. 5 to the x equals 28. Now we've already agreed that we could just take the log of both sides. And we also agreed that we could take the natural log of both sides, right? Well, what if we want to do it, what would we take the, what could we use instead of natural log and log in order to do this problem a little bit quicker? And as you think about that, this used to not even be a question I could talk about because we didn't have these calculators that can do all this stuff. So you'd have to pick log or natural log because that was the only thing your calculator could do. But if you understand that log base 10 of 10 to some number is just that number, instead of using log or natural log down here, what would be a little bit quicker? I mean, it still has to be a log of some form.
Base 5.
So if we did log base 5 of 5 to the x equals log base 5 of 28, right? Log base 5 of 5 is just x. And so then the question is just what's log base 5 of 28? And right, that calculator can do that. You can go down to that catalog, go scroll down until you see log base. So everyone put that in, log base 5 of 28. And what does that give you? 0704, the same thing as it did when we did it the other ways, right? We did it 3 different ways. So you can do any of these ways. Or you can say, I just am going to do log all day long and get the answer right. Okay? Depends how much you like math. Don't tell me because I don't want to be sad. Okay, so I don't have anything new to show you. We have to solve for x here. It is just an equation, and logarithms are just another tool to solve equations. So don't forget about all the other tools to solve equations. You still may need them. But we got to get x by itself, so what? What are we going to do?
Subtract 8.
All right, subtract 8 from both sides. Good. So then 2e to the x equals 32. That's an x. So you could do that if you did what?
Divide by 2.
Okay, so firstly, what he just said is perfectly legitimate. If you took the logarithm or the natural log of both sides, we can move the x out in front of 2e. Although that might be a little bit extreme because we can just divide by 2. Okay, so that's probably the more direct way. What he said is not incorrect. As long as you're sticking with your properties and you apply them correctly, you're fine. So now we have e to the x equals 16.
So then you can just cancel it with them. The answer is x equals natural log of 16. Right?
Okay, so yeah, you can't just cancel it. I mean, however you want to think about it is great. But so really we're taking the natural log of e to the x, or we're taking the natural log of both sides. When you take the natural log of e, you get whatever the exponent is. So now we have x equals the natural log of 16. And what is the natural log of 16?
77258.
7726. Okay, so could we have solved this problem by taking the log of both sides? Absolutely, okay? So don't think that that's, the only way to do these. We could have done it like Austin just said. We could have taken the natural log early and then moved the x out front and divided by natural log of 2e. That would have been fine too. All right, so what do we do? All right, add 120. So 10 raised to the negative 3x power is the same as 138. Yeah, be careful though, right? That's 10 raised to a power, so dividing by 10 wouldn't get us really that far. You could do it, but it'd be not what you think it's going to be.
Put log base 10 in front.
All right, so if we take the log of both sides, right, that would, because that's log base 10, that would end up canceling that out. So log of 10 to the negative 3x equals log of 138. And so then what ends up happening on the left-hand side?
Cancels out to negative 3x.
Equals log of 138. And so be careful on how you do this, because if you enter this into your calculator wrong, you might not get anything that makes sense. So I would do log of 138 equals, right, enter, and then take that answer and divide it by negative 3. But you should get what? 0.7132? Is that what everyone's getting? 33. Yeah, 33. Yeah, okay, so 33. I'll let it slide. Is that okay? All right, 2 more for me then. Okay, it's just an equation, so what?
Subtract 2.
All right, so then we have 6 times log of x equals 8. Okay, and you could go about this in a couple different ways now. But what do you think?
Divide by 6 log.
I would probably divide by 6. I think that'd be probably the easiest. What else could you have done there? What would be another option from that point that you could have done? Could apply to a property. Which property?
The power.
Yeah, the exponent or the power property, whatever. You could have moved that 6 up to the exponent if you wanted. It'll get you to the same place. It doesn't matter. But now what are we going to do? It's the thing I said at the beginning. What's that? Okay, so the log's already there, so you could, but that would be it'd kind of get messy. Well, what's the thing I said? If you remember only one thing about logarithms, it should be this.
Log is 10.
Log base 10, so how does that get us anywhere?
Put a log base 10 on the other side.
Well, that's what she wanted to do. And then you'd have on one side, you'd have log of x.
Okay.
So that'd be pretty obnoxious. But at the very beginning, I said, if you only remember one thing about logarithms, it should be this.
Oh. It's the thing with the thing.
Change it to the other form. So
Yeah.
what is that?
It's 10, and then the exponent's 8 over 6 equals x.
Okay, and so then what is 10 raised to the 8 over 6?
21.544.
4. Do we need another one?
3, 4, 6, 9.
3. Okay. Is that okay? So don't forget about that one. That's that's the definition of logarithms. That's supposed to be natural log, yeah. Subtract 9, so we'd have negative 3 natural log of x equals negative 3. Divide by negative 3, so we'd have the natural log of x equals 1. We still got one more.
I tried to divide by element.
No, you don't want to do that.
Is it just 0?
It's not 0. Say it again. Not 10 to the first because why? Yeah, it's not log. What is it?
E.
Yeah, so remember that this,
It's a 1e.
right, these two things are the same. Natural log is log base e, so then x equals e to the first, which is 2.71, what? Seven.
2.71828182.
That's good. Good enough right there. All right, is there any questions on that? Should be super easy. You can do logarithm the whole time. You never have to do natural log if you don't want. But you do need to know that the natural log is log base e. That is something that must be done. You can do natural log the whole time if you want. You can do log base whatever the base is if you would like to do it that way. But any of those are fine.